Hello, this is Professor Werwith. I was asked to take the last example from chapter 3 from the text and to walk through it step by step. I'm going to use the NPV formula from Excel as the preferred way to go through this. Let me remind people what the last example was about. Coleman Industries signs a 5-year contract to purchase water repellency chemicals for $7,000 per year for the next 5 years, starting next year. When the contract ends, the cost of the chemicals is expected to increase by 12%. So that's the inflation rate on the cost of the chemicals, right? And that's going to hold for the next 8 years. And initial investment now in delivery and storage is $35,000. So that's your times zero expense. In fact, everything on this analysis is an expense. The question at hand is, can you determine the net present value in year zero of all cash flows at I equals 15% per year? So the interest rate's 15%. We're going to look at all the cash flows, and let's get started. So basically year zero is going to be in the table as a $35,000 negative. We're going to have 5 years of $7,000 negative each. And then we're going to grow our expenses by 12% per year. Starting year 6, 7840. All I did was take the previous cell, C9, and multiply it by 1.12. That's a 12% growth. And then I copied and pasted that for the next cell, C11, C12, all the way down to C17. So what do we have here? We've got a stream of expenses, all negative, starting at cell C4 and ending in C17. But note that only C5 is the actual start of the annuitized annual expenses. The C4 expense is the initial C0 or time zero expense. So the way to do NPV, you just basically say equals NPV, open parens, 15% cost of capital, that's the interest rate, comma, the C5 through C17 cell range, right, which we talked about, that's year one through, C5 through C17, year 1 through year 13, okay? But remembering there is a year zero of $35,000 negative that I need to add in. So after I close the parens, I'm going to add C4, and basically that's already a times zero entity. So I don't have to collapse that. It's already there. And what's the answer? The answer is, just as we said before, negative 83, 229.95, right? So if I were to type it out again, basically it would be equals NPV, open parens, 0.15, which is the interest rate, comma. I'm going to highlight the range now. C5 through C17. And then I'm going to close the parens. And then I'm going to add C4, right? Negative 83,229.95, which is, oh, by the way, exactly what the textbook said, off by about 50 cents. The factor solution basically says you've got the gradient portion of the curve, which is 9 years, starting at $7,000. So this is PG, is the net present value of the gradient. PT for the year zero is the negative 35,000. We have to acknowledge that there's $7,000 per year for 5 years that needs to be brought into the present, right? And then we need to take the negative 49,000, treat that as a future value, and bring that into the present. So they've taken this whole segment here and broken it up into 3 segments. The negative 35,000, the $7,000 flat portion, and then the gradient portion. And recognize when you're doing the gradient portion, you have to bring that back to the present as well, okay? So that's, everything needs to be brought back to year zero. That's what you're doing here. So the spreadsheet solution I've shown you, the factor solution I've shown you, they both agree, negative 83, 232. If you like this approach, let me know. I can make some more videos in the future. Thank you.